In this video, I'm going to discuss binary to decimal conversion. But before I do this, I want to take a look at positional notation, or place values. I have the number 2,168 here. If we look at the place values of the number 2,168, we can see that the place values have the ones place, the tens place, the hundreds place, the thousands place, 10,000, 100,000, and million. These are the place values of the base 10 decimal number system. You can see that we have the number 2 in the 1,000s place, so we have two 1,000s. We have a 1 in the hundreds place for 100. We have 6 in the tens place for 60, and we have 8 in the ones place for 8. So effectively we have two 1,000s, one 100, 6 tens for 60, and 8 ones for 8. Now when we're talking about the place values in the decimal number system, we're talking about the powers of 10. You can see that the ones place is the 10 to the 0, the tens place 10 to the 1, the hundreds place 10 to the 2, or 10 times 10, which is 100. The thousands place is the 10 to the 3, or 10 times 10 times 10, and so on and so forth. So you can see that the place values are based on powers of 10. If we look at the number 2,168 then, in long form, we can see that effectively we have two 1,000s, one 100, 6 tens, and 8 ones, and 2,000 plus 100 plus 60 plus 8 totals 2,168. This is the type of counting and addition that we learn as children. The decimal system is base 10. It's based on the fact that you have powers of 10, but more importantly, you have 10 characters or 10 numerals in this counting system, from 0 all the way up to 9. So that means that in each place value, you can have anywhere from the number 0 up to the number 9. In other words, if I had the number 9,168, I'd simply replace the 2 here with a 9, and now I have 9 1,000s totaling 9,000 in the 1,000s place. So in any one of these place values, you can have the number 0 all the way up to 9. This is the base 10 decimal number system. If we consider binary and look at it in the same light as decimal, binary is a base 2 number system. There's only 2 characters, or 2 numbers, 0 and 1. So under the place values, we can only have zeros or ones. The place values go from 1, which is 2 to the 0, to 2, 2 to the 1, 4, 2 to the 2, 8, 2 to the 3, or 2 times 2 times 2 is 8, 2 times 2 times 2 times 2 is 16, that's 2 to the 4th power, place value of 16, the 32's place, the 64's place, and the 128's place. Notice that I extended the table to 8 place values. That's because 8 bits is an important grouping of numbers. 8 bits makes a byte in computer processing. So now I have the place values for essentially 8 bits. If I want to write the number 168 in binary, I just have to find the corresponding place values and plug in either a 1 or a 0. So I'll go to the 128's place and ask myself, do I need 128 to reach 168? Yes, I do. So I'll put a 1 there. Now, do I need a 64? I already have a 128. If I add 64, I would get 192 because 128 plus 64 is 192. So the answer is no, so I put a 0. I still have 128 now. Now, do I need a 32? 128 plus 32 is 160, so yes, I could use a 1 here. Now I have 160. Do I need a 16? No, that would make 176, which would go over my target number of 168. I'll put a 0 here. What about an 8? If I add an 8, I'll hit the number perfectly. 128 plus 32 plus 8 is 168. I'll follow this up with zeros in the 4's place, the 2's place, and the 1's place. And 168 in binary equals 101 01000. I now have one 128, I have one 32, and I have one 8. And 128 plus 32 plus 8 equals 168. If we go to the next slide, you can see now that I'm now charged with converting the number 01101101 to decimal. If I want to go the opposite way and convert this binary number to decimal, all I need to do is plug it into the place values. I'll put it in here, 0, 1, 1, 0, 1, 1, 0, 1, and then add it up. I have a 64 and I have a 32. 64 plus 32 is 96. Plus I have an 8, that makes 104. Plus 4 makes 108. Plus 1 makes 109. This number converted to decimal is the number 109. Now let's look at a full IP address in binary. I'll go to my next slide, and you can see in this next slide I now have a 32-bit IP address, 4 octets, or 32 bits total. If I want to convert this binary IP address to decimal, all I need to do is count up each individual octet. Let's start with the first one right here. We can see that 1, 1, 0, 0, 0, 0, 0, 0. 128 plus 64 is 192. Now, the next octet has 10101. Let's do that one. 0, 1, 0, 1, and then all zeros. If we count up the numbers, 128 plus 32 is 160, plus 8 is 168. The next octet is all zeros with a 1 in the last place in the ones place. This is easy. This is the number 1. All zeros and a 1 in the ones place makes the number 1. And then finally we have a number here. I'll plug it in here into my table. And I have the number 011000101. We can see that 64 plus 32, we've already said, is 96. Plus 4 is 100. Plus 1 is 101. So the conversion of this binary IP address to decimal is 192.168.1.101.